Hey everybody, welcome. We're going to get started. This is our talk, it's a technical deep dive into our recent application solutions showcase for mixed reality. This is a holographic experience. My name is Caleb Cannon, and this is my colleague, Ali Capiello. We're part of Object Theory. This is our team. This is an old photo. Not everybody's in there, but most of the crew is in there, and they're all very nice people. We're a full-service shop. We offer services from strategy, design, and through development. And for this project, we're fortunate to deliver across the spectrum in partnership with Microsoft. Our roots are in HoloLens development. I forgot to mention, we are 100% focused on HoloLens development as a development agency in Portland, Oregon. One of our founders was a tech lead with Microsoft on some of these projects here, including Maya, Trimble, the Autodesk, and NASA JPL projects. Since then, we've completed over 20 projects, some of which are pictured here. We're very fortunate to have worked with several Fortune 500 companies and many others. Some of these are standalone holographic experiences. Some are integrations with existing applications and services like Azure, desktop applications, and IoT devices. Here's our agenda. Ali's going to briefly overview the application, and we've broken it out into three main topical areas: guests, presenters, and creators. Those are our three user groups, and also the three main functional areas of the application.
All right, thanks, Caleb. To get started, I'm going to tell you a bit more about the application and some of its key features. So what is it? The Solutions Showcase for Mixed Reality is a holographic presentation tool that supports co-located shared experiences across multiple platforms, including HoloLens and iOS. It enables presenters to quickly build a custom mixed reality experience in any room. We also provide a codeless API for third-party content creators that works within this framework and offer a distribution platform for sharing content both publicly and privately. And who is it for? So as this application evolved, so did our audience. There are a wide variety of people in various roles who could use this application. There's Microsoft sales reps, retail center employees, partner companies with existing HoloLens solutions, and enterprise customers who want to learn more about solutions that are relevant to them in their business. So with all of this in mind, how did we create an application that supports all of these needs? Well, after taking some time to think about it, we were able to consolidate this down into three key audiences. First, there are creators. These are companies like us, Object Theory, or Trimble, who create content for the framework. Then there are presenters, such as employees at the Microsoft retail centers, that then use that content to build an experience for guests. And guests are the end users, the customers who actually experience that content and experience the demo. Each of these audiences has unique needs and goals that we needed to design for. So today we're going to touch on our learnings while building features for these three key audiences. First, this is a quick video walkthrough of some of the primary user flows in action. So right now, I just uploaded some content that was created using the SDK to the creator portal, which we'll touch on in more detail later. Then I'm able to go into the HoloLens application and add that content that I just uploaded to the portal directly into my scene here. And meanwhile, it is downloading from the cloud. This is the same bit of content that you just saw me upload. I'm able to then, as a presenter, position and move that in the room. And then I can use something that we like to call prompts, which can help guide users where to look and where to stand in the experience. So you just saw me create a very simple experience. I'm going ahead and starting it. So now I'm in the mode that your guests will see. So now I'm actually experiencing the demo that I made as a presenter. And there's my content. So there's two types of content that we'll be talking about today in the application. The first one we call scenarios, and that's really what contains all of the content for the demos. These are made by creators and used by presenters to basically create these experiences for the guests. The scenarios contain all the content for the demo. So there's 3D models, interactions, sounds, videos, and much more. And then you can basically string a few of these scenarios together to tell one narrative experience. Then we also have prompts. You saw me add one in there before that was called an air tap here. And these really help presenters create an experience to get the guest to stand in the optimal viewpoint or look in the correct direction to then experience that content. And we'll touch on that more in the next section, which is talking about the guests. So guests are customers or people who are interested in learning about real-world applications of mixed reality. If you tried the Solutions Showcase demo out over by the lounge, then you were seeing just the guest experience of it. And that experience is all about storytelling in 3D space. So guests need to be able to view and interact with content and learn about business solutions for HoloLens. And with the recent addition of our iOS app, even more people can enjoy the mixed reality experience. Today, for guests, I'm going to focus on a specific design challenge, which was helping people navigate in 3D space with limited assistance. And this can often be a challenge for new HoloLens users. And after building several of these storytelling applications for HoloLens, we learned a bit about how to do this more effectively and have some recommendations for you if you're interested in telling your own stories in 3D. All right, so we've touched on this a little bit, the prompts. Basically, to have the best experience in mixed reality, you always need to design with 360-degree content in mind. The next scenario may be behind you or even around the corner in another room. So how do we guide guests to the optimal place to view that content? So we created something called prompts, and it shows guests where to stand or where to look in the experience. And as you can see here, we also provide progressive feedback to reinforce that guests are doing the right thing as they're moving towards it. So as you get closer, there's a color change. You can't hear it, but the sound changes, it gets louder. And then you finally see a particle effect. So in addition to this being a really useful tool, it's also a bit of a magical moment in mixed reality. In addition, we also use spatial sound to help guests navigate. Since the HoloLens has amazing 360-degree sound, and you can hear in 3D space just like you do in the real world, sound is an extremely helpful cue for grabbing attention and providing context. So we use spatial sounds often and anchor them to 3D objects for rich, immersive environments. For example, you can anchor the engine sound to a holographic car, and as people move closer, it's just as if they were moving closer in the real world. And for navigation, the prompts use a radiating, looping sound, so as you get closer, you know you're heading towards the right thing. And within the scenarios itself, we also use spatial sound to draw attention to new or changed content in the scene. So we always recommend using sort of these directional audio cues to help reinforce the visual cues that you're providing in the experience. All right, lastly, we use attention directors to ensure that the guests are never fully lost in mixed reality. It can be very disorienting in a mixed reality experience when nothing shows up in the field of view. So attention directors are best practice to help draw guests' attention to the next piece of content. One specific learning that we had as a result of creating many of these self-guided demos for large trade show events is that the words "look left" and "look right" often didn't help people find content that was on the other side of the room or directly behind them. So we actually opted to use the words "turn to the left" or "turn to the right" and found that that would actually encourage people to turn their entire bodies and more easily find the next content. A few other quick tips for 3D storytelling if you're interested in getting involved. We recommend that you create a separate setup mode so that guests don't really see behind the curtain. I kind of like to think of it as Wizard of Oz. You want them to see the magic that you've created for them, but not see how it was made. We also use sound to bring everything to life. So use voiceover narration, background music, and additional sound effects to create that rich, immersive environment. And then we also recommend for self-guided experiences that you use timeouts for gesture interactions to make sure there are no bottlenecks in the experience. And even if guests don't quite get some of the gestures yet, they're able to complete it and experience the full story. Now let's talk a bit about presenters. So if you again, if you tried out the demo over at the Solution Showcase area around the corner here, the person who helped you get set up and was walking you through the experience was the presenter. So they're the ones who select what content you're going to use, place it in the room, and then start that experience for the guests. The primary goal is to be able to create this new demo in a very easily and quickly so that it works in any space that you might come to and need to do a demo at. The main hub for the presenter's work is called the Build Your Experience menu. From here, you can view and select content. You can download that from the cloud. You can change settings, load a saved experience that you created previously, and then actually go ahead and start that experience for your guests. And when you go and select content from the Build Your Experience menu, we built in 2 different levels of placement to make it easier and faster for presenters to place things in their environment. So the first step is a gaze to place. It'll be initially locked to your gaze. So when you look around, that allows you to very quickly get the content into the general area in the room instead of having to drag it or rotate it or move it all the way around to get over there. And then the second piece allows you to make some of those micro adjustments where you're able to use the gesture interactions with 6 degrees of freedom to move and rotate your content into the exact place that you want. And another important design challenge that we found for presenters was figuring out how do we show the order of the content in this 3D space, and how do we allow people to reorder that content as well so they can modify their experience on the fly. So we decided to place the order number quite largely on top of each of the calibration props that you're seeing here. And those numbers billboard to face you so that no matter where you're standing in the room, you can quickly look around and get a good feel for what your order is. We also then reinforce that with a visualization of the flow through the different pieces. So you can see there's an animated line that connects them in the order. And this allows you to very quickly and easily make a change, see that order update, and just get a really good sense of how your experience is going to flow through this 3D space. We also let people remove an object or lock it into place to prevent it from moving accidentally while they're adjusting other objects. In addition to the placement methods that we discussed before, we also make use of the spatial understanding capabilities of HoloLens to better align objects to specific surfaces in the room. So objects will snap to a floor or wall or table while placing. And this is really important because proper alignment to surfaces helps ground objects in mixed reality. In addition, it lets us sort of build in recommendations for how the content should be placed in the space. And spatial mapping is also crucial for building effective shared experiences. So I'm going to pass it back over to Caleb to tell you more.
So when we were putting this together, unfortunately, I didn't get a good capture of our spatial mapping setup process, but it is one of the important functions of this application. Like you saw in the previous slide, we use spatial mapping pretty heavily in the application. We use it in multiple ways, in fact. During the initial placement, we do a snap to surface kind of behavior. And here we have a different mode, which is a gaze-based placement. The key difference between those 2 modes is that in the first one, the raycasts are coming from the center of the object. In this case, they're coming from the user's origin. And the takeaway is that both of these are actually pretty useful. When you're creating an application, try both. One is going to feel better for your particular use case, or it might be a user preference. There is also a more passive but very, very important part of spatial mapping, particularly for an application like this, is that we use world anchors very heavily in the application. And to use world anchors effectively, your users have to create a good spatial map of the environment. So you want to make sure that you give them good indicators of how much of the volume they scanned, and where the gaps are. Why do we use world anchors so much? They're very important for 3 main reasons here. One is that they're used for stability and recovery. If your device loses tracking for any reason, or if you walk all the way across the room and come back, any object with a world anchor attached to it is much more likely to stay where it's supposed to be. We also use them for saving and loading layouts. Without the world anchors, it would be impossible to create this application. We couldn't save to disk, or load from disk. Which reminds me what I should mention for those who are new. A world anchor is essentially a position in real space And the world anchor is the way we save that position to disk so that when you start the HoloLens back up, it knows where to put that hologram physically. And finally, we use world anchors for shared experiences. And I want to point out that this app is a fully functional shared experience in that we have two multi-user modes. And this is kind of how we set that up for the anchors. We do a simple export. We get an object called a world anchor batch. And the key takeaway here is that we use an HTTP server to transfer the anchors. This is probably one of the dumbest pieces of code I've ever written in my life, this HTTP server. It has one job. You open a socket on port 80, it starts sending that file. And the reason we did that is that on the client side, it allowed us to use the existing download handlers that are part of Unity or UWP. Those download handlers are very functional. They come complete with error correcting, socket control, delegate methods, feedback, the ability to resume, things like that. So on the client side, it was very, very easy for us to bring these anchors in now, start the import process, and then have a multi-user shared experience. And this code also allowed us a lot of flexibility. We can put those anchors on the cloud somewhere or on some server in the middle or deliver them directly from the device like you see in this image here. Now we're going to move on to creators. This is where we're going to get a little more tech heavy. When we started this project, we knew that we needed to provide some certain level of functionality. We had one major constraint, which is that to deliver this content down from a web portal somewhere, we couldn't allow any third-party developers to write any custom code for the application. What that means is that internally we had to create components for Unity that would allow a developer to do basically anything they needed. So part of that is the creator portal, like I mentioned, and you saw earlier. This is a pretty simple CMS that we built on Azure. Users log in, they upload their content, then they create something that we call a showcase. That's what these checkboxes are about. As a presenter, you log into a portal, you're able to access the items in your showcase, and that content may be private to your organization, or it may be public content that some other organization created and shared. We log in with a QR code. There's a particularly good reason we did this. The alternative we looked at was assisted device login, which is a very good mechanism for HoloLens login. And Azure has a very nice package for setting that up. However, what we wanted was the ability for a single presenter to authenticate multiple devices very quickly without any sort of user interaction. That's what we got by using this QR code here. So as I said, for the SDK, we had to provide a lot of functionality for users without making them write any code. And the way we did that was by creating a whole bunch of Unity components that devs can kind of drop into their scenario or their content module and hook up in ways that gives them a lot of functionality like interactivity and the kinds of things you would traditionally do in code. We did work in an interesting way on this project. We siloed our teams. So to eat our own dog food, so to speak, we set up a dev team to work on the framework of the application and a design team to work on the initial content modules. They would say, okay, we need a component to do this. The developers would then create it and pass it over. But by setting it up in a silo like that, we were able to ensure that we didn't cheat and that we were actually covering all of the bases, producing things that third-party developers would need. As we were working on this, I found that the components were starting to fall into a few categories very naturally. The first one here we call triggers. And triggers are very important. These are how we get interaction into the content modules. We have triggers for things like air tap, for gazing at an object, for moving to a particular location. And the way we expose the hookup is through Unity events. And these are very simple to use. What I'm doing here in this animation is adding a input trigger for an air tap to an object that's essentially going to turn that object off when you give it an air tap. Likewise, in the sidebar, the user air taps on that button. That triggers an animation on the forklift to play in the background. We also developed a lot of modifiers. We call modifiers because they're more passive than triggers. Modifiers tend to work on enable or on disable. When they are activated, they really tend to modify the behavior of the application itself. So in this case, I have a bunch of cursor modifiers that are activating when I gaze at those different objects. We also have modifiers for things like background music. And one of my favorites is the position modifier. When you take a hand draggable, start moving it around, but attach a position modifier for snap to walls, for example, you get a snapping behavior when you get close to one of those surfaces identified in spatial understanding. Modifiers are also ridiculously easy to hook up. Here's me adding a cursor modifier to a gaze object, to a game object that, as you saw in the previous slide, when I gaze at those objects, it's going to change the cursor to a red dot or a blue square. That's how I did it, was just this 1 second step here. And then we have the catch-all other tools. And I wanted to point this out specifically because in these content modules, you do have access to a lot of existing stuff that we didn't even create. For example, the timelines in Unity, a lot of the stuff in the Holo toolkit, and a lot of other stuff that we created specifically to work with those modifiers, for example, changing materials. So now we're going to do an end-to-end of the SDK in action. And what I'm going to do is, starting from scratch, create a new content module, upload it to the portal, download it to the HoloLens, and view it in a shared experience without writing any code and without starting Visual Studio or deploying to HoloLens or anything like that. To create this, the only thing I brought into the SDK at this point was the raw assets. There's a tire and some textures and an icon. Those are the only things I brought in. And to prove to myself that this actually worked, I set up a timer. So this is running at an accelerated rate, but it is literally going to take about 4 minutes for me to create this module with some interaction via that start rotation button, and there's also a stop rotation button, and some animation using one of those tools that I talked about. So I've actually finished here. Took about 3 minutes and 30 seconds, and now I'm going to start the build. And the build took longer than the actual creation. You can see the time is going to jump to 7 minutes right about now. When this finishes building, Unity is going to pop open a folder with the build results, and I'm just going to zip this content up, give it a nice name, and pop over to the creator portal where I'm already logged in, but I can hit submit content, select that zip that I just created, and away it goes. And in just a few seconds here, this is going to be available publicly via the application. I'm going to add it to my showcase, pop over to the QR code, and that's it. We're done. So now we're going to pop over to the running HoloLens application. Now, unfortunately, I couldn't get a scan of the QR code scanning process because MRC doesn't work while the camera is active. But I logged in, and there was my content, so I started downloading it. And those last few bytes are always excruciating. Right about now. And I can start the experience, save my layout, and here comes that content. And I can hit that start rotation button. There's some animation now. I can hit stop rotation. And that was it. That took a grand total about 10 minutes to actually get it on the portal. And that content has all of the richness of the framework, including the shared experiences, the ARCA support for tablets, and the saving and loading, and the easy layout, and everything else.
Got this one. All right, so quick summary here. Here are a couple of the key points. We're running a little low on time, so I'm not going to hit all of them, but just remember to identify your audience, make navigation in 3D space a priority, make sure to build your application to be flexible and work in a wide variety of physical spaces. Really take advantage of all those unique features of HoloLens when creating your experiences. Learn the world anchor system inside and out, as Caleb discussed, and code for today, but design for tomorrow. We also have several other topics that are related to this application that we didn't get a chance to cover in detail. So if you're interested in any of these, come find us after this, and we're happy to chat about it. All right, and with that, from me, Caleb, and all of us at Object Theory, thank you so much for joining us today and learning about how we built the solution showcase for mixed reality. If you haven't had a chance to check out the demo yet, we recommend you go over around the corner here and get a demo. And enjoy the rest of the build. Thank you.